So this is a good review before your quiz. So going back to page 114, it is labeled 13.4, Problem Solving with Trigonometry. We are going to review right triangle trig in this lesson.
Is trigonometry like the best class?
724. Alright, then you need to glue in from 725 those two problems, 3 and 4. So from 725, 3 and 4. No, you do not need to skip any lines between them. We'll glue in the other stuff in a minute. So this is from 725, 3 and 4. We're going to do these two problems. Alright, it is possible to find the area of a triangle when you are given a side, and the angle in between. And that formula is written up here in the box up here. The area of that is equal to 1/2 the side length times the side length times the sine of the angle in between. Okay? This gets developed and comes from if you drew a right triangle and you looked at the relationship using trig, but we're not going to discover that today. So the area of this is equal to 1/2. What is one of the side lengths? Times what is the other side length? Sine of what is the angle in between? You need to type that in your calculator and make sure it is in degree mode. Always do that first. Radian is another type of degree measure that we'll talk about in a couple weeks. Okay, and it says rounds to the nearest tenth. So what did you guys get for the area? 0.3 millimeters squared. Do number 4. Alright guys, number 4, how am I going to set that up? What did you get when you plugged that in, though? Centimeters squared. There is another way to find area. On the back of your worksheet that we did the other day, the law of cosines, this is how you do letter C. Because it's asking you to find the area. Alright, now we're going to glue in what we had from page 727. So this goes on page 115. 115. The title is the same, 13.4, Problem Solving with Trigonometry. This is where we're actually going to practice our right triangle trig. We're going to have to fold it up. So we're going to glue in what we can and then fold up whatever doesn't fit at the bottom. This is from 727, that whole thing there. See, mine, even on a piece of notebook paper, doesn't fit, so I'll have to fold it up. Alright, so this is a review. Alright, we have a building that casts a 33-meter shadow when the sun is at an angle of 27 degrees. How tall is the building? So we want to know the height of this building right here. I'm going to call it H. They call it EF. We can call it, whatever we need to call. Height of the building. We need to find that to the nearest meter. We're going to answer this first question before we continue to read that. How tall is the building to the nearest meter? That's what number 6 is. So what are we going to do? It's been a while. You might need to flip back to your notes from 13.1 to 13.2. Remember, we need SOHCAHTOA. What degree do I have? Which one do I have? 27 right here. But what is 33 compared to 27? Opposite. And what is H? So which one am I going to use? Tangent. Tangent of 27 equals, what is the opposite? Over what's the adjacent? Okay, how do I solve one that's like this again? Yes. What's the first step to do that now? Times H. So H tangent of 27 equals 33, and then we do what? Divide by tangent of 27. What are you actually going to do to find the value of H, which is actually EF? Yes, does it say it around? Nearest meter. So in your calculator, you're doing 33 divided by the tangent of 27. When somebody gets that, let me know. 65 meters. Okay, that's the first question right here. It says, number 7, use another trigonometric ratio to find the distance of DF. That is, how far is it from the top of the building to the tip of the shadow? This right here. It says use another trigonometric ratio. Is there something else you could have done, though? You could have used Pythagorean Theorem. We don't want to do that because it got rounded way too much right here. So, what is this X right here? That looks like a plus sign. What is this? Hypotenuse. Okay, I'm going back to what I knew originally. I know the opposite and I know the hypotenuse. So what am I going to use? Sine is opposite in the hypotenuse. So sine of 27 equals what? 33 over x. It's the same setup, yes. That's a good question. Can I just use Pythagorean Theorem? No, because I rounded to 65 and that's way too, rounded. We need to not round that much. Alright, multiply by x. It's always more precise if we go back and use a trig ratio. So x times the sine of 27 equals 33. What do we do then? Divide by sine of 27. X equals 73, not x, df now, equals 73 meters. Last but not least, A says, use the fact that acute angles of a right triangle are complementary to find the measure of angle D. What is it actually saying? Find angle D. And how do we do that? 180 minus 90, which is 90. And then minus 27, you guys said? Which is, measure of angle D is 63 degrees. Does that kind of refresh your memory on what we did with those before? We're also going to do letter A down there below. You do have these on the quiz you're taking today. But you get to use your notes. Alright, solving a right triangle on the coordinate plane works very similarly. Except we are going to be lucky, and we are going to be able to use Pythagorean Theorem to find certain things. We are not given anything but the vertices of this triangle, and it's picture graphed out here. However, and I'm going to zoom in just on the picture in a minute, we have to find all three side lengths. So we're going to have to find AB, and we're going to have to find BC, and we're going to have to find AC. The side length should be easy. And we're going to have to find the measure of angle A, and we're going to have to find the measure of angle B, and we're going to have to find the measure of angle C. Seems like a lot. There are a couple of these that will take us no time at all. What do you think will be really quick to find? A, B, and BC. How are we going to find those real quick? Count. AB is 1, 2, 3, 4. 4 units. Okay. What else? BC, 1, 2, 3, 4, 5, 6, 7. 7 units. Somebody said there's something else that's easy to find. Angle B is 9 degrees. Do you know why? We could prove that they're perpendicular, but it meets right on that it's called a lattice point. They meet on the same point there. I mean, they could. That's coordinate point is made to be a square grid like that. Alright, the rest of these we have to find. Now, AC, do we have to use trig to find it? No, we can use Pythagorean Theorem. So somebody help me set up AC equals what? It's actually AC squared equals, but 4 squared plus 7 squared? Okay. I'm going to zoom in on this work. Because AC is the C value if I've got a right triangle, the hypotenuse. Alright, then what do I actually need to do though? It says round the side, find the side lengths to the nearest hundredth. So, before I actually get this together though, what am I going to need to do to get AC by itself? Square root. So, I need you to find out what AC is then if you're typing in the square root of 4 squared plus 7 squared. 0 what? 8.06 units. I've still got to find the measure of angle A and the measure of angle C. That's where I'm probably going to need some trig. Now, something we don't want to do. If we're looking for A or if we're looking for C, we do not want to use 8.06. Do you know why? It's not exact, it's rounded. We want to use the values that are exact. So I'm going to scoot over here. We're going to find A first just because it's alphabetical first. If I need to find A, what is 7 compared to A? And what is 4 compared to A? Which of our trig ratios is opposite and adjacent? Okay. Do you remember how we set up when we're finding the angle? Yeah, we'll use the tangent inverse. We say tangent of A equals what value? 7 over 4 because it's opposite over adjacent. Then we're going to use tangent inverse when we're looking for degrees. So in your calculator, you're going to type in the tangent inverse of 7 over 4. That will tell you what A is. It says the angle measure needs to be rounded to the nearest degree. That means whole number. 60 60 degrees. Do I have to use trig to find angle C? No. How do I find angle C? 90 plus 60 is 150. 180 minus 150. You also can just subtract 60 from 90. You can do that in every right triangle. 30 degrees. I have found all 6 pieces. I like doing it on a grid a lot better. It goes really quick. Because the only thing I had to use a trig ratio for was one of the angles. Are there questions about the 2 things we've done today? The area is actually not on your quiz. Okay.